Hi guys, welcome to our channel Helm of Science. I am Shoran and I had been discussing the chapter heat with you guys. So in my previous two videos I had been discussing the chapter heat. I had discussed the topic thermal expansion in my previous video. So according to it, we came to the conclusion that generally matter expands on heating and contracts on cooling. This is what we learned from thermal expansion, but it is seen in certain cases that it doesn't the all matters doesn't exhibit the following phenomenon when it's heated or cooled. So we'll come to the next topic, which is a rather important topic and an interesting one, which is the anomalous expansion. It is a very important topic and often questions are asked from this section. This is an unusual behavior which is exhibited by certain matter where it expands on cooling and contracts on heating. So this abnormal or unusual behavior is known as anomalous expansion. Now, what are the types of materials which exhibit anomalous expansion? Like we know water exhibits anomalous expansion within the temperature range of 0 degrees Celsius to 4 degrees Celsius. Anomalous expansion is also observed in case of silica when temperature is less than minus 80 degrees Celsius. So these are the two substances in which anomalous expansion is observed. So what do you mean by anomalous expansion? What do you mean by anomalous expansion of water? We can describe it as when water expands on cooling from 4 degrees Celsius to 0 degrees Celsius, then it is known as anomalous expansion of water. Now let's say, take an example, let's say in a beaker I have kept water. This is at room temperature, let's say it is at 20 degrees Celsius. 20 degrees Celsius. Now let me keep this beaker inside a refrigerator so that its temperature comes down. So after keeping it inside a refrigerator, we are observing the temperature. It comes down to 10 degrees Celsius, it comes down to 5 degrees Celsius, and so on. So while the temperature of water is coming down, it is observed that it contracts. The volume decreases and it contracts. So this is the natural behavior. This is the usual behavior of water. But when it is seen that it reaches 4 degrees Celsius and it further cools down to 0 degrees Celsius, during this phase it is observed that the volume of water increases, thus it expands. This abnormal behavior during from 4 degrees Celsius to 0 degrees Celsius is known as the anomalous expansion of water. Now if we do the reverse process, for example say that we have kept water at 0 degrees Celsius and we have started heating it. We have applied heat, so its temperature will rise. So it will rise up to 4 degrees Celsius. But in this phase, since we are heating, but like usually what will happen if we heat something, its volume will expand, but it is seen that it actually contracts, and from 4 to rest it shows the exact same properties, which is it expands. So in this temperature range from 0 degree to 4 degree Celsius, water exhibits this this abnormal property. Now, relating to this anomalous expansion of water, we have to plot two graphs which are very important for your exam. So first graph we'll plot is between volume and temperature graph. As discussed, when water at 0 degrees Celsius is heated to water at 4 degrees Celsius, volume the volume decreases, that is, it contracts. Again, from 4 degrees Celsius to 20 degrees Celsius, let's say it expands. It shows the normal properties. So keeping in mind this information, we will plot the graph. So we'll keep the volume in y-axis and the temperature in x-axis. So we'll keep the range by 2 degrees. So 2, 4, 6, 8, 10. So from 0 to 4 degrees Celsius, the volume contracts. So from 0 to 4, the volume contracts. The volume decreases. But from 4 to the remaining, it will expand. So there will be an expansion in the volume. The volume will rise. So the nature of the graph will be something like this. So at 4 degrees Celsius, we can see that it has the minimum volume. The minimum volume is seen at 4 degrees Celsius, and it is observed that volume of 1 gram of water at 4 degrees Celsius is 1 centimeter cube. We have expressed volume in centimeter cubes, temperature in degrees Celsius, and it is seen that the volume of 1 gram of water at 4 degrees Celsius is 1 centimeter cube. Now we'll plot the next graph, which is density versus temperature graph. Density versus temperature graph. Now, what is the relationship of density and volume? Density we know is known by mass by volume. It is in mathematical terms, it is described by mass per unit volume. So if the volume increases, density will decrease, and vice versa. So the relation is inversely proportional. So naturally, from 0 to 4 degrees Celsius, there is a decrease in volume. So naturally, as it is inversely proportional, there will be an increase in the density. Consequently, from 4 degrees Celsius to 20 degrees Celsius, the volume increases, so density decreases. So keeping in mind this relation, we will plot the graph. So again, similarly to the last graph, we'll keep density in y-axis and temperature in x-axis. Temperature is it is shown in terms of degrees Celsius and density in terms of gram per centimeter cube. Now if we plot the graph, we know from 0 to 0 to 4, the density will increase. There will be an increase in the density, and from 4 there will be a decrease in the density. Draw it again. Sorry. there will, up till 4 there will be an increase in the density, and from 4 the density will decrease. So it is observed that the density of water of 1 gram of water at 4 degrees Celsius is 1 gram per centimeter cube. The density is 1 gram per centimeter cube. 1 per centimeter cube. So density of 1 gram of water at 4 degrees Celsius is 1 gram per centimeter cube. Now I will be discussing an experiment which was performed by T.C. Hope, which explains that the density of water is maximum at 4 degrees Celsius. So in that experiment it is set up using 2 metal cylinders. It contains 2 metal cylinders. These are 2 metal cylinders, this and this. It is separated by a trough. This trough contains ice and salt. We have inserted 2 thermometers in this. This is thermometer 1, thermometer 1, which measures temperature. This is T1 degrees Celsius. This is thermometer 2, T2. It measures T2. Now this contains ice, and we have filled this 2 metal cylinders with water at normal room temperature. So initially T1 and T2 are the same. Initially they are the same because both of them contains water at room temperature. So T1 and T2 is same initially. T1 equals to T2. Now as it contains ice, so the water which is present near the center region, it will slowly, the temperature of water will decrease, and as the temperature of water decreases, its volume will it contracts actually. So its volume will decrease, sorry. So as it contracts, the volume of water also contracts, and so the density increases, right? As like this middle portion, in this center portion, as it contains ice, so water's volume will decrease, and so the density increases. So naturally it is seen that after a certain time this water, the density increases, so it will like settle down at this this lower metallic cylinder, and so the T2 temperature decreases and it reaches to a level of 4 degrees Celsius. So after some time this T2 temperature becomes 4 degrees Celsius as the ice reduces the temperature, but at the same time the T1 temperature remains the same. It remains the same. Since only the cold water which has higher density settles down at the bottom, the water in the upper part remains the same temperature, remains at the same temperatures. But after some time what happens is that this water, the water in the lower cylinder, the entire water is filled with water which is at higher density, and it is at 4 degrees Celsius. So after some time this center portion, this water will keep on reducing in temperature. So from 4 it will keep on reducing to 0, and we know that during this phase the water expands, so the density will decrease, and so water which is at 0 degree Celsius will settle down, will rise to the upper metallic cylinder, as the water at 0 degree Celsius has less density, so it will rise up to the upper cylinder. So after some time the T2 remains at 4 degrees Celsius, but the T1, there is a massive fall in temperature of the T1 thermometer, and it shows 0 degrees Celsius. There will be a massive dip in the temperature of T1, and it will show 0 degrees Celsius. So from this experiment we can conclude that the temperature T2 which shows 4 degrees Celsius, it is due to the water which is present at high density which settles down at the bottom. So from this experiment we can prove that density of water is maximum at 4 degrees Celsius. Now keeping in mind the anomalous expansion of water, we can conclude the following. This anomalous expansion of water helps marine organisms to survive, helps marine organisms to survive in cold weather. This is because in cold climate, when the temperature dips well below the minus degree, so what happens is that, let's say this is the sea level, this is the level of water. The water, the temperature dips down, so initially what happens, the water cools down, and so this density becomes high, so it will settle down to the bottom. When the temperature cools down further from 4 degrees Celsius to 0 degrees Celsius, so the density increases, and so the less dense water rises up and settles down at the top of the lakes. This water keeps on cooling down below 0, and so what happens is that it forms a layer of ice on top of the surface, on top of the water layer which is below it. So it will form a surface of ice. But however, this water with the level of water which is below the ice is at temperature which is at 4 degrees Celsius, which is optimal for the marine organisms to survive. So thus the anomalous expansion is responsible for the survival of the marine organisms. One disadvantage of anomalous expansion is that often it is seen that in cold countries, water pipes burst. This is because the water inside the pipes, they contract on cooling. So it will contract on cooling up till 4 degrees Celsius. They will contract till 4 degrees Celsius. But however, when the temperature falls down below the 4 degrees Celsius, what happens is that the water keeps on expanding, and thus it forms ice, and thus as it expands it bursts open the water pipes. So this is one a disadvantage of anomalous expansion. We can also give an example when we place a can of cold drinks inside our refrigerator and leave it overnight. What will happen is that when we open the refrigerator in the morning, we will see that the can will burst open because of this expansion of water from 4 degrees Celsius to 0 degrees Celsius. Thus these are the disadvantages of anomalous expansion of water. So these are few of the most important topics from the chapter heat. So in my next video I'll be discussing few of the most important questions which are asked from this chapter. So if you guys like this video, please share it among your friends and subscribe to our channel. So thank you guys, see you in the next video.